Now they signed me out of OneDrive.
Good.
I told on the desktop. They better give me a new laptop soon. Very. My friend who lent me this has a bunch of security issues in their laptop because they do like tax insurance broker and stuff. So their security is fighting with me.
Oh yeah.
You're going to go over this step, right? How to download.
Yeah, that's what I'm starting with.
Yeah.
Very small.
God, I hope they give me a new laptop soon. Kidding. So annoying. They told me that they're still ordering laptop because of all the chip shortages.
Chip shortages.
So who knows? I'm gonna get this laptop.
Well, how do you expect to do your job?
Like nothing we can do. Should be okay through Zoom. This will be easier. Is this pretty much everyone? Do you want to start? You can do introductions. Yeah. How do you know them?
I don't know them. Hello, everyone. Welcome to the RStudio. Today we're going to have a guest speaker, Dr. Ryan Ditchfield from the Department of Criminology, who's going to teach you guys our RStudio. Welcome.
Thank you. All right. Well, welcome everyone. This is, I don't know how many times I've done this workshop, probably like 10 to 15 times at this point, so it's pretty smooth now. What I'm going to do is I'm going to walk you through the basics of R and RStudio. I know that R can feel kind of intimidating. By the end of this workshop, I think you'll feel a lot better about it. A lot of the problems that you run into are usually in like the first 5 minutes of setup. And once you're past that, it's fine. So we're going to start, well, I'll tell you guys a little bit about R and about what we're going to do here. So 1, essentials. 2, we're going to show you some very basic data science and stats techniques. I think it's part of your, or at least for some of you, this is a homework assignment, I think, at least from what I've been seeing. So that's good. You guys will basically have me walk you through your homework. That's nice. And then we're going to cover 3 packages here. Dr. Hong, did you put the maps package in there for them too, in their homework or in their assignment that you gave them? Okay, I'll show you guys that for fun if we have time. That's a geospatial package that lets you visualize data with maps, exactly what it sounds like it does. It's pretty fun. As far as what you can do with data science, why are we doing this? There's a whole bunch of different things. And I do want to make clear, it's not that you need to go into a career in data science or in statistics or anything like that. Knowing stats and knowing data science opens a lot of doors for you within your specific career you're interested in. Mainly because a lot of people are terrified of it. And so if you are the person at your job that is not terrified of it, or at least is not scared to try it, that means that people will be coming to you and you'll suddenly become a resident expert in data science, whether you like it or not, which means that you've got a lot of job security, you can open up doors for promotion, and you can find some better paying positions as well. Because a lot of these jobs pay better because people are scared of them, right? So that's why these are good skills for you guys to have. I always tell my students, you don't want to only do the things that are easy, right? That will not get you ahead in the long run. You want to seek out those things that are hard, that are challenging, so that you can grow as a person and as someone in your career. That's what ends up helping you to grow the most, is when you find those things that are challenging and you overcome them. But that's it. I'm going to show you guys first how to download R and RStudio. This is step one. Who here has downloaded them already? Good. Who here still needs to download? A few of us. Okay, good. So this is pretty straightforward. I think a link was provided to you guys, right? So you just go here. This is the website that you want. It is posit.co. This is correct. I know it feels like you're like, where the hell am I? But this is the correct website. You're going to need to download and install both of these. First thing you do, download and install R. As long as you have a computer, doesn't matter if it's a Mac or a Windows, it'll be fine. If you have a tablet, I don't think it'll work. If you have a Chromebook, it will not work. Do you guys know Chromebooks are not real computers? I hate to say this. They're just web browsers. So that if you're running into problems, double check that you don't have a Chromebook, because that could be causing all of your problems. It only lets you install web apps. That's where a lot of these things come in. Okay, that's it. Once you've installed R, you're never going to open it again. You're only going to open RStudio. So this is the one that you want to download. RStudio, as I'm going to show you in a second, is what everyone who is sane works with, because it has a user interface. Base R is just a command console where you have to write code. RStudio has point and click things, like you can import files, you can save your code for later, so you don't have to rewrite it every time from scratch. So it does a lot of very helpful things. So no one who is sane ever uses base R. Everyone uses RStudio. So while most of you guys sound like you've downloaded it, I would recommend opening RStudio now. And then you want to open up your, you guys should have the student code, right?
Yeah.
Good. So you can open up, if I can pull it over here. There you go. Open up your student code right here. There it is, student code. I'm going to be using a different file at certain points called a quarter markdown file. Don't worry about that for now. That's basically just a fancy R script that lets me make it look pretty for you guys. It's just for looks. Let me show you what that looks like, actually. So here we have RStudio. Notice that mine looks different, right? It looks like an actual Word document. You can do this. You can actually easily do this if you are interested in using. The base thing is an R script. If I do this, this is what you should be looking at. Do not type things into the console down here. This is R down here. I don't recommend typing in the console because it won't save anything. And the whole point of using R, as opposed to any other statistical software, is that you only need to write your code once. And then once it's written and it works, you never have to do it again. You open it up, you click run, and it'll do everything for you immediately. And if you want to run the same analysis on a different data set, you just copy and paste the code over, and it'll run the exact same way. So it's one of the main benefit of R. Well, actually, there's two main benefits. One, it's completely free. And most of the textbooks on it are free as well. That's really nice. As opposed to SPSS. Has anyone here ever tried to buy an SPSS license? How expensive is it? Nightmarishly expensive, especially when you're not a student anymore. Then it's like thousands of dollars per year. Crazy. Whereas R is free, always will be free. And the textbooks are almost all free. So that's why we teach it, even though it's got a sharper learning curve. The other benefit of this is that most of the work is front-loaded. In SPSS, when you're doing the point and clicks, you have to go through the point and click process every time, and you have to check boxes and you have to do everything. It doesn't take a lot of time when you're used to it, but it does take a bit of time every time. And it's not very sophisticated. It's like 15 years out of date. I don't know why they charge money for it, to be honest. Whereas R, once you've written your code, it's done. That's it. And R is always up to date because the best data scientists and statisticians in the world and researchers, they all use R, which means that the state-of-the-art statistics and the state-of-the-art methods are all being published using R, not SPSS. So it's not only is it free, it's also the best thing. Okay, so once you get here, just make sure that you open up an R script. It should look like this, just a blank white box with a number 1 up here. I would actually recommend that you guys start with the student code, which you can see I've already written in. I gave you guys this code so you don't need to do it from scratch, because that's kind of the whole point of R, is you shouldn't be doing things from scratch. It's totally fine to copy and paste from what other people have done. That's the whole benefit of it. So if you want, I'll give you guys 2 options. You can type manually here. I don't recommend that. That'll just take a while. Or you can open up your student code and you can just follow along as we go through it. Sound good? Any questions so far? Okay. Then let's quickly go back here because I have a couple things that I want to mention about how R works before I show you the actual code. First of all, we'll come back to this when we get to the end of this workshop, and I'll show you guys some really cool stuff of visualizing for a lot of you guys. Well, what fields are you in? How many people here are education? How many people here are criminology or FBS? Anyone here not in those fields? Which fields are you guys in? Psychology? Okay, well, I'm a psychologist, so that's, yeah, makes sense. I'm just a psychologist in a criminology department. Actually, psychology is arguably the one field that uses R the most. Yeah. So all of you probably should, it's good that you're learning this. But for visualizing in particular, if you're going into any field that requires looking at data, which is pretty much all of us, most people who aren't trained don't want you to throw numbers and formulas at them, right? They want things to be easy to understand, which means visualizing the data with pie charts, bar charts, that sort of thing, and making them look pretty. There's nothing better than R at making graphs look pretty. That's arguably its best function. So that by itself makes it worth learning. We'll come back to that later. Here is the R environment. You can see that there are 4 boxes. This right here is your source box, your script. This is where you're going to put all your code. This lets you save it like a Word document. And that way, when you open it, you don't need to start from scratch every time. Down here is the console. This is actually R. You can see over here. This is why you have to download base R first. And RStudio just opens it up in this corner down here. Over here, we have environments. I'll explain this in a bit. This creates things called objects to put up here. An object is basically just anything that you're defining in R. So it could be a data set, which you guys will be doing. It could also be like a formula. So I'll show you guys. You can actually just do basic algebra in R very easily. You just say x equals 3. And it'll create an object over here called x with the value of 3. So very, very simple. And then down here is your output, mostly for plots. This is where your beautiful plots that you make will show up and where you can download them. Don't worry about that for now. First things first. Has everyone opened RStudio? And does everyone have that student code opened up? Good. We're going to start by loading the necessary R packages. And then we're going to set up the working directory. And then we're going to import the data. This is where most people run into issues. So I'm going to walk you through this. If we have to take the most time on these steps, that's fine, because this is the most annoying part. Once you know how to do it, it's easy. It's just R doesn't tell you what's going wrong. You just have to know. That's what I'm here for. So what is an R package? It is basically It's like basically giving a new function to R. So R by itself can do some really basic math. It works as a regular calculator, but that's about it. It can do a bit of stats, like intro stat stuff, but very, very basic. If you wanted to do anything fancy or cool, anything intermediate or beyond, you need to install packages to give it additional functions. So it's basically giving it a new language for it to work with. So number one error that I see people make is they try to run R code without first loading the package associated with that code. And R will give you an error saying, I don't know what the heck you're talking about. I've never seen this in my life. It'll give you an error like can't find function. That's basically telling you it's missing the package that lets it know what that code even means, which is why you always put your packages, what we call, I'll show you, that's library code. It's the code at the very top of your student code. Run those first every single time, and you have to start by running them. That way, R doesn't think that you're crazy. For a working directory, has anyone here ever heard of a working directory before? I know. This is like a lost art. Anyone who like built PCs or worked with like Windows 95, something like old PCs, you would know how to work with this stuff. But that's kind of like a lost art form. A working directory sounds scary. It's not. It's just telling R which folder to look in. That's all. R doesn't know by default. There's not a search function or anything. You need to tell R, look in this specific folder. So what I want you guys to do right now, on your desktop, create a folder called RStudio Workshop or something, a new folder. Here, actually, let me show you guys how you can do that. So if you go to your desktop, if you're on a Mac, it should be pretty similar. This is on a PC. PC, you just right-click. I think on a Mac, you do command-click, something like that. And you can create a new folder. Let's go right down here, new folder, name it something like Workshop or RStudio Workshop. And then I want you to put all that code that you have. So the student code, the data set, I guess it's just those two things right now. Put that into that folder. And from now on, every homework assignment, every data set that you get for class, put it in that folder. This way, you don't have to reset the working directory to a different location every time. I know that you guys probably have it sitting in your downloads folder right now, right? That's causing problems. It doesn't know where your downloads folder is. So you need to make a new folder, put it in there. I'll give you guys a second to do that. Yeah.
So I just finally downloaded everything. I'm just trying to remember off memory. So I have to open the
RStudio.
RStudio, I don't ever open the R.
Correct.
I open the student code. So I open the student code and then do this folder.
Correct.
Okay.
Yes. All right. Now, let's actually go to R. And let me zoom in. Way too small. You can zoom in by doing Control plus or Command plus if you're on a Mac, or zoom out with Control minus or Command minus. You can also make these windows a little bit different size, like so. All right. So when we are running code, and first of all, see this green line here? This is what we call in-text annotations, or just, yeah, I mean, you can call it annotating your own code. These are just lines that don't do anything. They're just notes to yourself, or in this case, notes from me to you guys, telling you what the next line of code does. To do this, all you have to do is you put that little hashtag. So notice if there's no hashtag, it goes to black text. That's bad. That means R thinks that it's real code. We don't want that, because obviously it's not real code. And see how it puts a big X there? It's like, what the heck are you talking about? And anytime you see those X's, I mean, something's gone wrong. So to fix that, we're just going to put a hashtag back there. And see how the red goes away, the red X. Now we're good. So it says this code installs the packages and sets the working directory. So what we're going to do, all you have to do is, you don't have to highlight the whole line, you can. You actually just need to click on that line. And then you can go up here and hit run manually, or you can even see it tells you what the shortcut is. You can just do Control Enter or Command Enter on a Mac, and it'll run it. And notice down here in the console, it ran the code. It says library tidyverse, and then it says attaching tidyverse packages. Tidyverse is actually a set of a whole bunch of different packages. It's what we call a universe of packages. They're all really useful ones. So that's why we run it first. It gives R a whole bunch of handy things that we're going to be using, including reading data sets into R. Kind of useful. ggplot2 is for graphing. It actually is when you install tidyverse like this, ggplot2 is included. Now, for some of you, when you run this line, are you running into any trouble? Or did it run and you got the same thing? Yeah.
Why is this not my function?
For just this one, library? Oh, you've gone too far.
Oh.
You ran this line here. You just need to run just this first line here, library tidyverse. Okay, good. Okay. You can also run ggplot2. That's not going to change anything. And then maps. Now, when you run this, you might run into a problem. It might tell you this package doesn't exist. Is anyone getting that? Something that looks like that. So this means that the maps package just isn't installed. So I'm going to show you how to do this. Over here, you go to packages, and then you hit install. And then you literally just type in maps, the name of the package, click on that, and then you hit install. You only need to do this once on your computer, and you never need to do that again unless you get a new computer. So if you're running into that, you can do that, but don't worry about it. If you don't, we might not even have time to cover that. So it's not a huge deal. Okay, everyone okay so far? Does anyone have any questions about the packages? And has anyone run into any errors on these? Good, that's fantastic. Yeah.
No, I do have an error. It just says there is no active file. Is that because I didn't move it to that folder yet?
No, if it's which package is it telling you doesn't exist? Tidyverse?
Library.
Okay, so what this means is you're going to do the same thing. Go to install, and you're going to put in tidyverse like this. And then you hit install over here. So again, just go to the packages tab over here. You can also, tidyverse should already be here. Like that. See how it's checked? There's a checkbox. That means that it's loaded. If it's not there, when you search for it, that means you haven't installed it on your computer.
Okay, yeah.
Perfect. Yeah, it'll take a little bit of time to run, but then it should be good. Anyone else have any questions about this? Or running into any issues? Okay, good. All right, next thing. Let's talk about the working directory. So, has everyone created that folder on your desktop? Good. Do it now if you can. Yeah. Just the code, the student code, and your data set. Basically, think of it as a home for everything you're doing with R. And then, I mean, in that folder, you can also make some subfolders. So like, if you have like different classes where you're using R, you might want to make some subfolders for different classes, just for organization's sake. But that's not necessary for this one. So, yes.
So, email two data and then exonerations data.
Exonerations.
Oh, that. Was it both of them or just the exoneration?
Where's Dr. Hong?
That's for a different part of homework.
Okay, so put both of them in there. We're just going to work with the exonerations.
Okay.
That way they're in the same place. All right. Now, what I want you guys to do over here, go to Files, and you should see, actually, I created a temporary desktop for you guys just so that it looks blank. You want to navigate to your desktop on your computer. You want to find that folder that you made. For this one, I made a folder called RStudio Workshop. And then click on it. And then inside, you should see, you know you're in the right place because you'll see your data set and you'll see your code. I'll give you guys a second to get there. Yeah. So just go to your desktop. This is, by the way, this file function here, this is your computer's like directory. Don't delete anything here. It'll delete it from your actual computer. And if you create a new folder, it'll create an actual new folder on your computer. So I've made that.
Oh.
Yeah, so if you go home, you should be able to like, let's see. Where did I put it? Temporary, yeah, temp desktop. I just made a new blank folder called desktop for your sake, just because my desktop has a whole bunch of different folders, files, and stuff on it. Yeah. Anyone run into any issues? Okay. Everyone who's okay to move on, give me a thumbs up. Good. All right. Once you're inside of this folder, so you can see this stuff, you're going to go to see this little like gear thing here. It says more settings. Click on this. And you're going to go down here to set as working directory. I'm just going to leave this here for a second. So again, click on this gear, go down here, set as working directory. When you click on that, it is going to run the code right over here. See how it says set WD and the RStudio code. Take this code down here. Oops. Yeah. And then copy it. You can just do like Control-C or Command-C. And then go up here, and you're just going to paste it up here. This means you never have to do that again. Notice it's the exact same code. It was the exact same code that was right here. So again, let me go through this again. Make sure you're in the correct folder. Go here to the gear. Click on this. Go down to set as working directory. Click on this, and it'll run this code down here in base R. So notice that means that this has not saved it, right? It has set the working directory to the correct folder already. But for the future, you want to highlight this and copy and paste it up here. Don't include the little arrow over here, by the way. That arrow it doesn't mean anything. So just make sure you copy just that code, put it up here, and then up here, we can run it. And notice it does the exact same thing as going through and doing it manually. So this is just going to save you guys time in the long run. I'm going to pause there. Does anyone have any questions or is running into issues with that?
Question. Like a recording that kind of gives a screen, like the same thing you're doing now.
We're recording it right now.
Okay, perfect.
Yeah.
I'm running into difficulties with my screen, so I can't access certain buttons.
Okay, yeah, we're recording it on Zoom. All right, now, this little code here, get WD. What do you think WD stands for, by the way? Working directory. It's actually pretty Straightforward. Set WD is set working directory. Get WD is get working directory. So this is just a way to double check that it's in the right spot. So we're going to run get working directory. And down here, it's going to give us the output, and it's going to tell us that the working directory is this location. So just make sure that it looks like the right spot on your computer, not some random spot. It should say the folder at the end here. Okay. Any questions? This is the most difficult part. Once we're all on the same page for this, it'll be smooth sailing. Okay. Everyone good? Good. Next thing, we're going to go down here. I'm going to show you guys how to install that data set, how to upload it. To do this, we need to define the data set as an object. We can call this data, this object, anything. I'm going to recommend you call it data. Easy. Just to show you guys, you can define it as anything. See this little arrow here? Just that little like that less than, greater than. I should know this, I'm a mathematician. One of those. And a little dash. That's just an arrow pointing at that. That is defining that as an object. You can do this for anything. So for example, if we go down here into the R console, I'm just going to do this directly so it doesn't save it. We could define, let's say we want to make a variable x, and we want to define it as 3. And we just hit run. Notice that up here, it has created an object called x with a value of 3. Let's do another one. Someone give me some number that we want to define this as. Which says 5. 5, sure, that's fine. Now we have an object called 5. Okay, now this is cool. X plus y. 8. Isn't that handy? In other words, you don't need to tell it 3 plus 5. It already knows what x and y mean. You can do other things. X times y, 15. You can do x times 4 plus y times 6, 42. So in other words, it'll let you do basic algebra way easier than doing it by hand, right? So it's just a fancy calculator at its most basic. That's all. Now, that's the most basic way to define these objects. You can clear your working space by hitting this little eraser thing. Yes, remove all objects. Now the environment is empty. Now what we're going to do is something fancier. We're not going to define a single letter as a single number. We're going to define an object called data as an entire data set. Which I know is a big jump. So we're going to go here. See this read CSV function? What is a CSV? Yeah, a comma separated value file. It's like a Excel sheet, but more basic. It can be read by most programs. So if you have an Excel file, you need a different code. What do you guys think it's called? Read Excel. Yeah. Most of these functions do exactly what they say. So this says read CSV. It can read CSV files. Your data set, the exonerations data, is a CSV file. We know this because at the end, the file extension says .csv. So we're going to run this line here, Control+, and notice that it created an object called data with 3,500 observations of 23 variables. A big data set. And if you click on this, it'll open up that data set right over here. Look at that. I'm going to give you guys a second to do that. And I want you to get to the point where you have this tab open with data and you can see these same variables here. That will tell you that you got to the right spot. Yeah, sure. So all we need to do is see this code, line 11, where it says data, read CSV. Just click on that line, Control Enter or Command Enter. and it'll run it. And then you can run this next line, view data, and that'll do exactly what I just did. View data is just the way to open this without clicking on it. You can do everything in R without clicking on anything, technically. But RStudio lets you have some functions to actually point and click things. So technically, every time you click on data, see how it ran view data down here? So it's technically running that view data function every time you click on it. That's all. And who here has gotten there or is running into problems? Okay. So tell me, what does the error code say?
This does not exist in the current working directory.
Does that mean, what do you think that means?
Not in the working directory.
It means it's not in the folder that you told it to look at. It doesn't know where that folder, where that particular file is. So again, to double check this, you want to make sure that you go back here, open up that folder, and make sure that you have the data in here. Data here is exonerations data 2024 right here. Don't change its name. It needs to be exact. Yeah.
When I'm running the CSV, I'm just running, it says could not find the function.
So that means that you haven't run tidyverse. So again, this is why we're going to make sure that we're running this in the right order. So tidyverse, when we run it, it includes, actually, so tidyverse includes, because remember, tidyverse is a package made up of other packages. It includes the package that lets you open CSV files. So as long as you run tidyverse and you don't get an error down here, you know you didn't get an error because this little extra arrow shows up telling you can run the next line, then you're good to go.
When I try running tidyverse, it gives me 3 warning messages. That tidyverse forecasts in Louvre days were built under a different R version.
That's not a problem.
Okay.
Yeah, you can ignore that. Some of the error codes, you can ignore them.
Okay.
Yeah.
Okay.
R gets updated almost every month. So that's all it's saying is it's basically telling you, hey, we haven't updated this to the most recent version, probably just because the authors of that package haven't gotten around to it yet. As long as as long as the function is running, it's not a problem. Okay, anyone else running into any issues? Has everybody gotten to the point where they can see this data? Who cannot see this? Okay, what error? So where are you getting hung up?
Now I don't know.
You maybe accidentally deleted it. You could do Control Z, see if that'll bring it back. Giselle and Stacy, would you be able to help?
Yeah.
Okay. Anyone else need any help? Again, this is the most important thing where people get hung up on. Is once you have the data set installed and open, everything will be fine after that. Okay, everyone good? Good. Next thing. I'm going to run this next line. So notice we're just doing one line at a time. Don't skip lines. Because if you skip down to the bottom of your code, that could cause some issues for you potentially. It might run, or you might get an error and not know what the error means. And the error is usually because the code later in the document needed you to run a line of code further up. And it won't tell you which line you needed to run. So just go from the beginning and go one at a time. So we're going to run this. This is names. This function just tells us what the names of our variables are. This is just a quality of life thing so that we know what each variable name is. That way, if you wanted to, for example, analyze a different variable, you can just go here and copy and paste it. I never recommend manually typing in R for any reason, because R is case sensitive. For example, see this time served variable over here? if I did lowercase t times served, R is going to look at me like I'm crazy. And they'll say, that doesn't exist in this data set. And it's just because it's not a capital T. So that's why I always recommend, rather than typing in manually, go down here, highlight it, control, and you can actually just double click on it and it'll highlight the whole thing, and then paste it. That way you get the exact spelling and the exact formatting. This is one of the reasons why I recommend keeping your, like anytime you're running like a Qualtrics survey or creating a new like questionnaire or anything like that, or creating a new data set, make sure that your data set you're feeding into R is as clean as possible and that your variables are all formatted the same way. Make sure, one common issue that I see is sometimes when you download from Qualtrics, it'll randomly put an extra underscore for some variables. That's annoying. Why does it do that? I don't know. These are just common things that I've run into that you'll go mad unless you know it's a possibility, because it's such a small error, but it'll make your life impossible because it just won't run and you won't know why. So just be aware that that can happen. That's why data cleaning is the most important and most tedious step, but the most important step. Okay. Did everyone get this? All your variable names? Good. Now we can actually do some data science. So let me tell you guys a little bit about this data set, first of all. I'm a legal psychologist, forensic psychologist. So that means that I work in psychology at the intersection of law and psychology, mainly social cognitive psychology. I do a lot of work on wrongful convictions. This data set is from the National Registry of Exonerations. This is, at least as of 2024, I haven't downloaded the new one because then I'd have to clean it, which is annoying. But as of 2024, this is every person who has been exonerated in the United States. And all the reasons that they're exonerated, as well as, for example, their names, their age, their race, their sex, the state that they're in, the county, and the crime they were, the worst crime they were accused of, at least, the sentence they were given, the year that the crime happened, the year they were wrongfully convicted, the year they were exonerated, the amount of time that they served. Again, exoneration means that they didn't do the crime. So these people are all innocent and served time in prison for something that they didn't do. Important data. And then over here, these are variables I created for you guys. These are just the reason why they were wrongfully convicted. Why did they go to prison for something they didn't do? This variable here says that it was because there was a witness who mistakenly identified them. This one here says that there was false forensic evidence planted against them. So somewhere along that stage, either at the police investigation stage or the prosecutor stage, someone made up evidence or fabricated evidence that led to them going to prison for something they didn't do. This is a false confession. So usually through coercive interrogation, they confess to something that they didn't do. Over here is inadequate legal defense. This is false accusation, perjury, and this is prosecutorial misconduct. So this would be like prosecutors hiding evidence, for example, not telling the defense. You're legally obligated normally to disclose evidence to the other side, both directions, during the discovery phase of a trial. But in these cases where there's a one, the prosecutors didn't do that. So they had evidence that would have proven the person was innocent, but because that hurt their case, they just didn't say it existed and hid it. So a lot of problems in our field that can lead to these, as you can see. What we're going to do some statistics on today is to figure out which of these causes are the most important, which one should we be focusing on, and has it changed over time? Because we have put a lot of time and effort in our field into trying to solve these things, so you're going to see, have we actually made a difference? Make sense? The actual one we're going to do here is this variable at the end, WC cause, wrongful conviction _ cause. I made this variable for you guys so that we don't need to do some complex stuff with each single variable. This is converted so that I put all of them into one variable. It just makes it a little bit easier, guys. Questions about the data set before we move on? So this is just, I wanted to give you guys a data set that's actually real world impactful data for us to work with. Show you guys, we don't do data science with, not just for fun, right? Sometimes I do it for fun. But in our actual work, we're doing work with data that impacts real people. Whether you're in education, where you'll be working with data that'll impact children, teachers, schools, school districts, right? And people's education. Or if you're in criminal justice, obviously you'll be working with data like this, where it'll impact people's lives and at bare minimum, potentially crime rates in your community, or people going to prison for things they haven't done. So very, very important data. This code right here, where it says summarize and mean. Have you guys covered mean, standard deviation, range yet? Good. What do you guys think this code does? Yeah. This is why, I mean, R looks intimidating at first, but can you see that it's actually pretty simple once you get it running? So the way this works, see this little function here, one that looks a little bit weird, is what we call a pipe function. This is from the package Dippler from the tidyverse package. So this function here will not work unless you have run tidyverse, just as a heads up. If you're getting an error, that means that you need to go up to the top and you need to rerun this library code right here. So what this does is when R sees this, it knows you're telling it, look inside this object. So in other words, the way that we read this is R, look inside the data object, this data set. And inside this data set, I want you to summarize time served, and I want you to give me the mean, the standard deviation, and the interquartile range. And it's going to give all three of those numbers to us immediately. This na.rm equals true. Just keep that there. That tells R not to panic if there's missing data. Because if you don't put it there, I don't think it's a problem for this data set, but for a lot of data sets, you might have missing values. And R will just freak out. It'll say, I don't know how to calculate the mean if even one cell is blank. This little extra line of code, the na.rm equals true, says it's okay. You can still do it. I believe in you. And then it'll do it. I don't know why that's not the default. So it's basically you just got to tell R that it's okay. I feel like sometimes you have to be like a parent to R. So if we run this, you can see it's automatically going to run. And it's going to give us these numbers here. Let me actually make this a little bit smaller so it'll all show up. If this screen down here isn't big enough, it won't give you all the numbers. So notice how it doesn't have the interquartile range. And now it does, because I made the screen bigger. So what does this mean? What is the average amount of time served? Let me zoom in again. 12.2. What does that 12.2 number mean? What is the average amount of time served for wrongful convictions? 12.2 years. Yeah, pretty long time. This is a standard deviation. That means that there's quite a lot of variation between people, right? So that means that some people might be serving only 6 months. Some people might be serving up to 30 to 40 years. There's a lot of variation in the data, which if you just eyeball the actual data itself, you'll see that that's absolutely true. If you go up here, you can see that there's 14, 16, 6, 4, 38, 3, 4, 4, 4, 0. That means that they were wrongfully convicted and then immediately released, right? So there's a lot of variation in the data. So standard deviation is useful to tell us that it's not all the same. People are having different experiences. An interquartile range, by the smaller again. 14 basically just means that this is looking at the 25th percentile, lower 25th to the 75th. This is looking the middle 50% of all the data. What is the difference in years from the 25th to the 75th? And it says that there's 14 years there. So this basically tells you there's a pretty wide range across the data. That's all. Because you're wondering, why don't we just take the highest and lowest value? Why do we take the 25th percentile, 75th? There could be extreme outliers. So the interquartile range lets you avoid those outliers. It's just a general recommendation for how you quantify range. Slightly more complex version of range. But I think for you guys, I don't know, do you guys use interquartile range for your class, or do you just use regular range, which is highest minus lowest? Do you guys know? Both are correct. It's just which one you're using. Questions so far? Good. All right. That's pretty straightforward. Now we're going to visualize this. This is with ggplot. I'm going to make this part over here bigger for you guys so that you can see the plots that are going to come. So now notice right now it's blank. Now we're going to run this where it says data type function ggplot. Ggplot just means graphing. It stands for grammar of graphics. That's what the GG stands for. AES stands for aesthetics. How do you want it to look? So we're going to say ggplot aesthetics. We're going to plot on the x-axis, the bottom axis. We're going to plot race. We want it to be a bar graph. Geom stands for geometry. What is the shape of the graph that you want? Geom_bar is a bar chart. And then we're going to do theme classic. I'm going to show you guys what each of these do. The nice thing about ggplot is that it's very customizable. So notice, this is a very basic one. We can actually make this even more basic. So I'm going to highlight the theme classic. I'm going to delete it. I'm going to rerun it. Notice that now it has this really ugly, like gray box behind the bars. Annoying. I like how things look, so this annoys me. What the theme classic does, you just go over here. You're adding an ingredient. This is literally like you're building a recipe for your bar chart. You do plus, theme classic, not plus plus, just plus. And theme classic, when we run it, is going to just take away that gray box behind it and add lines on the x-axis that are in black. So it makes it a lot cleaner. In case you're wondering, yes, there are lots of other themes that you could do. So theme underscore so, and it'll actually tell you all the options. So you guys tell me, what other theme do you want to test here? There's theme classic right there, obviously. Minimal? Yeah, let's try minimal. And notice if you just click on it, it fills it out for you immediately. That's minimal, I guess. It still has those lines. I guess if you like the lines, it's fine. Personally, I'm not a fan. I like theme classic. Like that. Oh. There we go. Yeah, so you can play around with that, see which ones you like, that sort of thing. Now, this is a pretty boring graph, right? It's just black and white. Has everyone gotten here, by the way? You got this bar graph up here? What I'm going to show you next is I am going to make this prettier. First things first, notice how right now this bar graph is just in alphabetical order, right? Or actually, it's not even alphabetical order. It's just in like, yes, it's alphabetical order. Where white is last, Asians first. Is that a really meaningful or helpful order? Not really. What would be better? What would look more visually pleasing? In descending order, right, exactly. So we would want to have the category with the most first. So we want black as the first category, white as the second category, and so on and so forth, right? The way we do this is with this one, changing the order of categories. We're going to tell it, look at data, the object. We're going to overwrite that object, the same one, using this within. So we're saying, look inside this data set, look at the race variable. And then this race variable, which is an object inside of this object, we're going to say, well, you can just copy and paste this. We're going to use the levels code right here. Levels just tells this is the order I actually want it in. Then we're just going to manually type in the order that we actually want. Factor here just means that it's their categories. Factor means category in statistics. So we're going to run this. It is now reordered. And now, if we go back and rerun this, look at that. Now it is in a much better order. It's actually in descending order. Still in black and white. So you're probably wondering, well, how do you add color to this to make it look even more pretty? That's pretty simple. What we're going to do is we're going to do the exact same thing. We're just going to add one little line of code. We're going to do after the X race, we're going to do comma, fill. And I don't want it to just be different colors for fun. I want that color to mean something. So we're going to fill it. And fill automatically tells R, this is going to be different colors. We're just not specifying colors yet. It's going to choose it itself. We're going to show you the breakdown for types of wrongful convictions within each bar. So you're going to get a lot of information here. Run this, and look at that. You can immediately see that if you're in the African American / Black category over here, the vast majority are mistaken identifications by witnesses. The other category down here is still the largest one. That's because it's kind of like a catch-all. Most of these are because of prosecutorial misconduct, actually. So that's a big area for our field that we're addressing now, that we only recently identified in the last 15 years. Mainly because we didn't even know that that was something that was happening. So this data here tells us where to focus our research on. Okay, questions so far? Good. Next thing, notice how it just gave us these colors, but we didn't choose those. It just manually picked those for us on its own. Those are automatic. If we want it to have a specific color, we absolutely can. So we're going to do this, same code, and then we're just going to add this little plus at the end, and we're going to tell it scale fill manual. This little code here, what does it sound like it does? Fill manual. We're going to manually pick the colors ourselves. Yeah, that's all this code means. Let me move this over so you can see all of it. So if we look down here, one of the nice things about R is that when you type in a color like this, it'll actually highlight it with the color that it is. So this is royal blue, and that it is highlighted with royal blue. We could change it if we just go to just regular blue. Now it's regular blue. We could do dark blue, and now it's dark blue. I think there's, I don't know how far we can go with this. Is there indigo? Find out. No, indigo is not an option. We'll say dark blue is fine. Start with dark blue. I'll show you guys where to find all the different colors. These are the base R colors, like the ones that R already knows about. You can find any color in existence in R. In fact, you can just specify the hexadecimal code. So technically, you could just go to Lowe's or Home Depot and go to the paint section, and it'll tell you the hexadecimal code for that color. And you can just put in the hexadecimal code right there instead of the name, and you can do that. So you can literally, like you're painting a house, you can go and get a color swap for the graph color that you want. It's the most customizable possible. I'll also show you guys there's a website where you can find themes if you're not that into like art and paint and color. You can go and you can look at different options that are already available for themes. So it can be pretty fun. I'm just going to run this, and you can see here that now we have manually changed the colors over here to be the ones that we want specifically. So that's bar charts. Next thing we're going to do is we are going to create a scatter plot, or no, sorry, a box plot first. Box plot is basically a way for us to visualize the mean, median, and the range of the data to see if there are any outliers. To make a box plot, the only thing that's going to change here is, well, we're going to put time served on the y-axis. So we need a quantitative or continuous variable here. Up here, we were just working with categories. Down here, we're going to run this, and it's going to give us this box plot telling us that there's a lot of outliers on the high end. So this means that most people are serving around 10-ish years, 12-ish years. But there are quite a few people who have served significantly longer than that. This is why we don't just do the regular range, and why a box plot is helpful, because it shows us those outliers at the end. I think this third one here is a man named Richard Phillips. I went and had dinner with him a few years ago. He served 64 years. Yeah. Okay. Now we're going to do a scatter plot. As you might imagine, the only thing you need to change here is this little thing where it says geom. We're changing the shape. The scatter plot code is just geom point, because a scatter plot is made up of little dots. Run that. And there's your scatter plot. This is showing you the correlation between age and time served. Why did I pick those? only because you have to have two continuous variables, and those are the only two continuous variables in this data set. So I had no choice. Those are the only ones I could use. Not super exciting, but there you have it. Now this is okay. What might be more interesting is if we can add some color here, right? This, by the way, this blue line here is what we call a regression line. You guys will learn that later in stats. So to add color, we're going to color code this by wrongful conviction type. And you can see here that the vast majority of cases, if we make this, zoom this out here, vast majority of cases are the other cause, like prosecutorial misconduct or false evidence, that sort of thing. However, and this is an important point, notice that the blue dots here are all the way on the far extreme end of years served. What this means is that the people who have served the longest period of time in prison are not for that other cause box. It's eyewitness memory that has contributed to the longest time served for people for something they haven't done. So the most serious one is eyewitness memory. Even though it's not the majority of it, it's still the most serious cause for us to look at. And then finally, I'm going to show you guys a time series plot, the last one. You can see it's a little bit more complicated with the code because we have to set up a few things here. So for example, we want to make sure that it's grouped by a few different things like the year they were convicted. You have to do that so that it knows what the time is on the axis. Just trust that this is correct for now. And then we want to also label. So notice over here, it automatically put the label as the variable name. That doesn't look very professional, right? With the underscore. You can add in the xlab / and ylab. That changes the label of the x-axis to a custom title for you. So again, nice part about R is that you can customize your plots as far as you want to go. You can even change the font. So if you want to have Times New Roman in your plot, you absolutely can. I'm going to run this, and there we go. There is our time series plot showing you the distribution of identified causes over time. Notice over here, this big red spike, this is for other cause. So in other words, what this is telling us is that we've identified all those other, that new branch of like prosecutorial misconduct, false evidence, that sort of thing. That's a relatively recent discovery in our field. And only recently have people started to be exonerated for those things. In case you're wondering why, it's because up until the 1990s, not very many people were getting exonerated at all, right? You can see that before this, not very many people were being exonerated for any reason. It was only in the 1990s when DNA became a thing, DNA evidence, and DNA let us definitively show that someone was innocent, even though they were in prison. So that's where you see the spike beginning in the 1990s. And then now that people know that wrongful convictions are a real thing that happen, now we've been able to say we can exonerate people even if we don't have DNA, if we have a lot of other evidence pointing to them being innocent. Because unfortunately, DNA is only present in like less than 1% of cases. So you have to be ironically lucky to be wrongfully convicted and have DNA be present proving your innocence. The odds of that happening are pretty small. So it's nice that we've shifted away. But I do want to note here, notice that mistaken IDs, the number of people exonerated from mistaken eyewitness IDs spiked in the 90s and has gone down since then. Part of that is because we've done a lot of research on this in our field, and we have implemented best practices to change how lineups and eyewitness identification procedures work dramatically. They work better now. Before it was the Wild West. Now we actually have laws and procedures, and as of 2019, California requires a lot of those best practices by law. So in other words, if you don't follow them, the person will go free. So police departments have a very, very strict incentive to follow those procedures now, which is one of the reasons why we've seen this as a cause go down. That's a good thing. That means the science is working. All right. That's all the code in your student code. Last thing I'll show you is the map, just because it's kind of cool. This is not on your homework or anything, but I do want to show you what R is capable of. Has anyone here ever done like anything geospatial, like mapping or anything? not usual. This is something that you do if you're like in engineering or in geography or that sort of thing. Or in like city planning, they use geospatial mapping a lot. Usually they use a program called ArcGIS, which is a very expensive program, costs a lot of money, even more expensive than SPSS. And that's mainly because they have like coordinate data that's already uploaded and they can visualize and all that. Except that now R has it for free. Which is awesome. The way it works is you just create an object called polygons, define it using map data. All we need is in our data set here, we just need to make sure that we have a variable called state or county, whatever location it is. And the R package will automatically know what the coordinates are, like the longitude, latitude is for that based on the name of the state. So it'll automatically, it's really smart. It'll already automatically be able to do it for you. You don't need to look up the latitude, longitude yourself. So we did that. Map data. This one, we're going to just lowercase it. It doesn't like it when state is uppercase. State map, we're going to left join. This is just saying we're joining this object and the polygons object. The polygons object is just the raw coordinate data for the entire world. It literally has like, it's more fine-tuned in some places. Like United States, you can get down to the street level. Somewhere like North Korea, you'd be lucky to get like regions, just because they're not releasing that. So it does depend on where you are in the world. But most countries do have really specific coordinate data. We're going to do that one, and then we're going to run this, which is going to create a plot, and it's going to literally, it's going to take a little bit of time to run, mainly because what it's doing is it's creating a blank chart, and it's going to slowly draw it with little dots over time. So it should come up here, assuming this computer is strong enough to do it. It doesn't show up. Oh, there we go. Thank God. Okay. So what this is showing you, this is a map of the United States. It just drew this by hand, and it's showing you by state which states have the longest average time served. In other words, which states do you not want to go to if you're worried about getting arrested for something you didn't do? I don't know if it's particularly shocking that it's Florida in the South, but yeah, it is. Okay, does that make sense? All right, that's it. That's all the code. See what I mean by it goes a lot faster once you have everything loaded up and you can open your data set. And then you literally just go through and you hit run, and it's done. Any questions for me? Right, let me show you one thing before we go, because this is, I think I might have a link on the PowerPoint actually. Yeah, rgraphgallery.com. We'll open up this one, and we'll open up this one. There we go. So first things first, for you guys, I'm going to recommend, if it's not already in your syllabus, there are several open source textbooks out there that are really helpful for this. So there's this one. There's also R for data science right here. Oh, you can't see that. Let me open up. This is book here, R for data science. You can just Google this. It's free. It's just available as a website. You can pay money for it to get a physical copy, but that money that you pay just goes towards this parrot. That's it's a New Zealand parrot that's endangered, and the person who wrote the textbook is a biologist who studies that parrot. So he did this as a way to be a charity to get funding for that bird. So if you'd like to pay for the book, that's where the money goes. But it's free, and he says so on his site. This is another one, our graphics cookbook. I think this person studies moose. There's a lot of biologists who use R and write the textbook. I wonder where the money, I assume that it goes towards moose. Either way, it's completely free. This is what we call an R graphics cookbook. Exactly what it sounds like. It's a recipe book for building graphs in R. So if you're ever like, I want to know how to build a graph and I'm not sure how, you can just go here and you can go down and see how to do it. These are just really basic ones. You just go to bar graphs, for example. It'll give you the code, and you can literally just copy and paste the code here and put it into R, and then run it, and it'll create the graph for you. Only thing you need to do is change out the name of the data. That's it. And you can get as complicated as you want, going all the way down. This is the R Graphics Cookbook is at simple graphs. But if you want to get really crazy, you can go here to the R Graph Gallery. This is another website. It's really fun. You go to chart types, and you can see here that there are a stupid number of visualizations that you can do in R, up to and including things like animated graphs. So if you want to make an animated graph to present to people, you absolutely can, and it shows the different types of animated graphs. You can show how relationships change over time, right? You can show a time series chart where the line moves as time passes. There's some really cool stuff you can do here. Some of these chart types, I'm like, I don't even know what this means. Like, where is one? Some of these I've never used in my life before. What would you use a dendrogram for? I don't even know. I guess in biology for species. Yeah, that makes sense. So really cool stuff. And look, you can make some really pretty ones. Yeah. And then over here, here's another tool that I really love. You can go into Color Finder over here, Color Palette Finder. And this is what I was talking about earlier. If you're not sure about what theme you want, you can go here and you can find a theme that's pretty. You can see a whole bunch of them. There's just an alphabetical order right now. You can go down. If you click on Filter, you can also specify a target color. So like, for example, I really like purple. So then it'll show you all of the different themes that are purple coded. So you can also do it that way.
What was the website?
rgraphgallery.com. Anyway, this is obviously optional, but long term, for like if you go into a career, if you ever have like your boss say, hey, could you make me a visualization of like our school data for this year, for example, you can make the best graph they've ever seen in their life. Yeah. Okay. Questions about this? Or any questions at all for me? You guys feeling a bit better about it? Good. R does have a sharp learning curve at the beginning, but once you get used to it and you're comfortable with it, you'll never go back to anything else. Mostly because it's free. And you'll get annoyed at even the thought of paying money to do something like this. Okay. That's all I have for you guys. Did we end on time? Sort of. A little bit over. Yeah.
We save the script maybe for reference later.
Yes, absolutely save the script. Yes.